All right, chapter 12 is our last chapter in Unit 3, and it's all about experiments and observational studies. In an observational study, researchers do not assign choices. They simply observe them. The textbook's example looked at the relationship between music educations and grades. They noticed that students who took more music classes or had more music education had higher grades. That's an association, a positive association. However, since the researchers did not assign students to get music education and just simply observed students out in the wild, in other words, those students were already signed up to take music lessons. They didn't tell them, okay, you take lessons and you don't. So we just kind of observed what was happening in the wild. It wasn't controlled. Then that is what is an observational study, as opposed to an experiment. In an experiment, which we'll talk about in this chapter, you control, manipulate what's going on. Because the researchers in the text example first identified subjects who studied music and then collected data on their past grades, this was a retrospective study, meaning they just they looked at data that already occurred. Had the researchers identified subjects in advance and then collected the data as it unfolded. So if I kind of looked and said, okay, who studies music, and then I watched your grades happen over the next year or two, that would be a prospective study. So we have retrospective and prospective. Those are two vocabulary words you definitely know. Observational studies are valuable for discovering trends and possible relationships like associations and correlations. However, it is not possible for an observational study, whether prospective or retrospective, to determine a causal relationship. So we're back again to correlation or association does not equal causation. Not always is a true statement. In observational studies, at best, we can determine relationships, but not cause and effect relationships. Moving on to experiments. An experiment is a study design that allows us to prove a cause and effect relationship. So here is the first time that we are actually allowed to get down to a cause and effect relationship, and this caused that. Even then, just because you do an experiment doesn't mean you should automatically be 100% sure this causes that. Your experiment needs to be well designed, well controlled, and we'll talk about what that means, and replicated. But moving on, in an experiment, the experimenter must identify at least one explanatory variable called a factor. This is kind of like an X variable, except we can have more than one. We call them factors in experiment, and they will manipulate and control this factor, and there will be at least one response variable that will be measured. So we're going to control a factor, an X variable per se, and we're going to look to see what happens to this other variable as we could change and control and manipulate this factor. And it could be more than one factor. An experiment manipulates factor levels to create treatments. Randomly, that's important, assigns the treatment and compares the responses of the subject groups across treatment levels. In an experiment, the experimenter actively and deliberately manipulates the factors to control the details of the possible treatments and assign subjects to those treatments at random. That is 100% has to happen. Assign subjects to the treatments at random in a well-designed experiment. If the subjects choose which treatments they get, not an experiment, an observational study. The experimenter then observes the response variable and compares responses for different groups of subjects who have been treated differently. In general, the individuals of whom or which we experiment on are called experimental units. However, that's a horrible word to use for people. So instead of when the humans are involved, they're usually just called subjects or participants. But if you hear experimental units, they're talking about who the experiment was done on. The specific values that the experiment chooses for a factor are called the levels of the factor. And a treatment is a combination of specific levels of all factors that an experimental unit receives.